this. Alright guys, so today we're going to start our unit on trigonometry. First of all, I want to bring your attention that we are starting at 4.3 rather than at 4.1. It just makes more sense that way for the way I want to run the lesson. And we're also going to skip to 4.8. So we're doing 2 lessons today, but they're actually super short. Okay? Alright, here's why we're starting here. First of all, I'm going to need you to kind of take a moment and go back to geometry for a second. Okay? In geometry, you were introduced to simple trigonometry for the very first time. Correct? What do you guys recall about what you learned in geometry as far as trig? SOHCAHTOA. That's typically what I hear. SOHCAHTOA. You learn 3 of the ratios. You learn the sine ratio, the cosine ratio, and the tangent ratio, right? And then you learn that acronym of SOHCAHTOA to help you remember. But here's my question before we even get started. What are they? What is it? What is sine? What is cosine? What is tangent? What does that mean? Because a lot of times I don't like to start this unit because then you're going to start learning and memorizing all these things, but then you can't answer the most basic question, which is, what are they? We are going to get to radians. We are going to get there. But what is it? For example, if I ask you, what is sine? What is sine? Iman, what do you think? So I always get that answer. So it's opposite over hypotenuse. But what does that mean? What is it? It's a what? So if you're doing opposite over hypotenuse, you're doing like a fraction, right? We're doing a ratio. So they are ratios. Typically, what does a ratio do? It's like a proportion, and it helps you compare. Agreed? So like back to like elementary, the first time you learn ratios, they'll be like, there's 2 boys for every 1 girl, right? So you're comparing boys to girls, and you could figure out how many total there are on a huge amount just by using that simple ratio, correct? It's proportional, okay? So I'm going to repeat the question. So what are this? What are this sine, cosine, and tangent? What are they? Starts with an R. They are ratios that compare what? Sides of a right triangle. Okay? Do not forget that. We're making ratios comparing sides of a right triangle. So if you want to write down somewhere in your notes that, go ahead and do so that you don't forget what it is that we're doing. We are comparing sides of a right triangle. Okay? Now, everybody, first of all, we're going to be using the Greek alphabet a lot now that we're in trig. I'm going to post a file of the Greek alphabet on the website, so make sure that you access the website if you're not familiar with it. So the most common Greek letter that gets used with trig is this symbol right here, and it actually looks like that, and this is called theta. Okay? So here's what I want you to do. You have a triangle here. I want you to label one of the acute angles as theta. So go ahead and do so. I'm going to label this one here. If you label the other one, it doesn't really make a difference. Okay? Now that you have your angle labeled, tell me which one would be the opposite, which one would be the adjacent, and which one would be the hypotenuse. Opposite, hypotenuse, adjacent. Cool? It will make a difference if you chose this to be your theta, then this will be the opposite, that would be the adjacent. Agreed? Okay. Alright. Now, what do you remember as far as geometry? Well, all of you or most of you guys said SOHCAHTOA. Okay? Remember, in case you don't remember, SOHCAHTOA helps you as follows. S stands for sine, and remember, sine is actually written that way. This is just a shortcut. You do not read it as sin. It's sine. Okay? So this says sine is O. O stands for opposite. H stands for hypotenuse. So that means the sine is opposite divided by hypotenuse. C stands for cosine. And we just shorten it by saying COS. Cosine. And cosine is what? Adjacent over hypotenuse. And tangent is what over what, guys? Opposite over adjacent. Okay? And those were the three ratios that you were exposed to during geometry. Agreed? All right, well, there's actually more trig ratios that you're going to have to memorize. Okay? And they're as follows. The following three ratios are reciprocals. I want you to underline, highlight, put a star, something that's going to bring your attention to that. They're reciprocals of the ratios that are right above it. Okay? What is a reciprocal before we move any further? Okay, be careful when you use the word opposite. The word opposite in math means that if I have 2, opposite of 2 would be negative 2. Is that what a reciprocal is? No. I know what you're trying to say. Be careful. We have a fraction, so for example, let's say I have A over B. The reciprocal would be B over A. This is a reciprocal. Are we okay with that? All right. Now, so I'm telling you that these are reciprocals of the one that's right above it. Now, this one got cut off, but it looks like this, CSC theta. That stands for cosecant. So cosecant of theta is the reciprocal of sine. So what does it mean? How are you going to find cosecant? Hypotenuse over opposite. Very good. The next one, it's called secant. And secant is the reciprocal of cosine. So we find it by doing hypotenuse over adjacent. And very last but not least, we have cotangent. And that's the reciprocal of tangent. So that means it is adjacent over opposite. Secant? Secant, it's... Okay, that brings me to a very good point, and here's what I want to clear out. Most students make the confusion that saying that secant and sine go together, and that cosine and cosecant go together because they hear the word cos, and then they hear the word s. Actually, it's the way I remember is you have to think opposite. Cosecant goes with sine, and secant goes with cosine. So notice how you have SC, and then you have CS. That's how I remember them. So that's the most common mistake, and it happens. Most people want to think it's, I hear the word co, so that means those go together, and then the sine and the secant. Okay? It's actually cosecant goes with sine, and then secant with cosine. Are we cool with that? Whatever way you want to memorize it, you can do it. That's what I use. Okay? So here are the 6 trigonometric ratios, and you're going to have to memorize them all. Typically what I do, to be completely honest with you, is I memorize this first 3, and then I just do the reciprocal of them. Okay? But if you want to memorize all 6, go for it. Okay? Alright. Now, before we go any further, these ratios originated from an angle, correct? In this case, from theta. That has a name, and it's called a reference angle. And your reference angle can make a huge difference, because what if your reference angle was up here? Then you see how no longer would you have the same opposites, and no longer would you have the same adjacents. Okay, so that reference angle makes a huge difference. Cool? Alright, so now I'm going to show you how to apply all of these 6 trigonometric ratios. So let's jump to example number 1. You have a right triangle, and we're going to find all 6 trigonometric, and that shouldn't say functions, so scratch that out. That should say ratios. My apologies. 6 trigonometric ratios of theta as shown in the figure. Give exact values, no decimals. Okay, we're really moving away from decimals. Okay? Alright. We have a reference angle down here. We have our opposite. We have our hypotenuse. And we have our adjacent down here. Agreed? Do have my hypotenuse and I do have my opposite, but I don't have my adjacent side. You need to figure out what your adjacent side is. And if you did your homework, you can do this without doing any math. But let's say that you're not seeing that. You can use what other mathematical procedure to find out the adjacent. The Pythagorean theorem. Agreed? Couldn't I use Pythagorean theorem to figure that out? Okay, let me ask you something. The measure of the hypotenuse is 4, and this right here is half of that. Special right triangle. Which one is it? So what would theta have to be there? And this would be the 60. Do you guys see that? Because then 30, that would be x. That would be twice as big. And this would be what? The adjacent would end up being what, guys? Which in our case would be 2 root 3. So do you guys see how your special right triangles, knowing them, can help you save time? Does that mean that if you didn't remember, you can figure out that that was 2 root 3? You could go through the Pythagorean theorem and you still get the exact same answer. Are we okay with that? Alright, so now for time's sake, we have all of our sides of our triangle. Now we can find all the trig functions, correct? I mean, ratios, pardon me. So if I do sine of theta, so sine of theta is opposite over hypotenuse. So in our case, it becomes what? 2 over 4, which simplifies to be 1/2. Leave it as 1/2. Do not write it as 0.5, please. Okay? What's the cosine of theta? What is it, guys? 2 root 3 over 4. Technically, you're right, but you're going to have to simplify this. What's going to happen with the 2 and the 4? So, could I then simplify it to just be root 3 over 2? Yes. Are we okay with that? Awesome. Tangent. Alright, so tangent of theta. Tangent is what over what? So, opposite in our case is 2, and adjacent is 2 root 3. We have a couple things that we need to do here. What's going to happen with the 2's? They're going to cancel out, and then you're going to be left with 1 over root 3. Agreed? You cannot have a root in the denominator, so how can I get rid of it? So multiply both top and bottom by root 3. So this becomes root 3 over, what's root 3 times root 3? 3. So the tangent of theta is root 3 over 3. Cool? Now, if you find those, how can you find, for example, what is the reciprocal of sine? What is it called? Cosecant. So cosecant of theta, without having to do any work, can you use that answer to come up with cosecant? What is it? Awesome. Right? It's just the reciprocal of it. What is the reciprocal of cosine? It's called what? Secant of theta. Now, if we do the reciprocal, then this becomes 2 over root 3, right? We have a problem. What are you going to have to do? So rationalize it, right? So it becomes 2 root 3 over 3. Cool? What is the reciprocal of tangent? Cotangent, right? So notice how it started with 2 over 2 root 3. So this time it's 2 root 3 over 2. What happens to the 2's? Leaving you with root 3. Agreed? Okay. Here's my question. And I got ahead of myself here. What is theta? It's an angle, right? In our case, what angle is it? Theta equals 30 degrees. So is there a way that I can rewrite all this using the 30? Absolutely. If you know that theta is 30, so couldn't I just say, and you don't have to write this, couldn't I then say sine of, instead of saying theta, I could say sine of theta of 30 equals 1/2. Cosine of 30 equals square root of 3 over 2. And so on. Do you guys see what I'm saying? Okay? Good. I need you to put a star by that problem. Okay? You're going to need that for your homework. So keep that in mind. Alright, I'm going to do one more with you, and then I'll let you try example number 3. You have a not a rectangle, you have a square, and I want you to find the sine of 45, cosine of 45, and the tangent of 45. And I'm telling you that each side of the square is 7. Well, it's very important for me to tell you that this is a square because that lets you know that this is a right angle. That also lets you know that that's 7. And this diagonal is cutting that 90-degree angles in half, right? Making them into 45s. What's the length of your hypotenuse? 7 square root of 2. Now we're good to go. Because now I have my triangle, I have everything I need, I can answer the questions. So, sine of 45 degrees. Wait a second, I have two 45-degree angles. Which one do I use? It doesn't matter. You can use, okay? So let's pretend I'm going to use this top one right here. So if I use that top one as my reference angle, what's the opposite of that? The side. So the opposite would be 7, and the hypotenuse would be 7 square root of 2. Notice how the 7s are going to go away, right? And then you're going to be left with 1 over root 2. And you have to rationalize. So it becomes root 2 over 2. Cool? Cosine of 45 is adjacent over hypotenuse. So what's your adjacent side? 7. And your hypotenuse is 7. Wait a second, that looks exactly like sine. Can I avoid doing all that work? So what is the answer? What's the cosine of 45? Square root of 2 over 2. Last but not least, tangent of 45 degrees. Tangent is what over what? Opposite over adjacent. So opposite is 7, adjacent is 7, so that makes it 1. Put a star by that problem. You're going to need it for your homework. With your partner, I want you to try example number 3. Turn your cups to red and then turn to green when you're ready to move on. Alright, so I need you to check your work. So because we have an equilateral triangle, you know that this is 8. And because this triangle has been cut in half here on the base, that means this is 4 inches and this is 4 inches. Therefore, you automatically know that this is a 30, 60, 90. Actually, you should have known that priorly because it's an equilateral triangle, right? So this was 60, this is 60, and that's getting cut in half, so that's 30, and that's 30, right? Because this is 4, then that makes this 4 root 3. Agreed? Now you have everything you need. Sine of 60, you should have gotten square root of 3 over 2. Cosine of 60, you should have gotten a half. Tangent of 30, square root of 3 over 3. And cotangent of 30 equals to the square root of 3. Questions over those? Well, I have a question for you, I'm sorry. Well, you got that cotangent of 30 equals to the square root of 3 on this problem using these numbers. But if you go to example number 1, remember how we found that theta was 30? So technically, isn't this cotangent of 30 equals to square root of 3? But these are different numbers. Why did that happen? Why does that work? What are these? They are ratios. And what do we know about ratios? Proportional. Okay? No matter the fact that they're different numbers, what did you just discover about the angle 30? The cotangent of 30, I can care less what the measurements are, it's going to be what? Root 3. The tangent of 30 is going to be root 3 over 3. And guess what? Coming very soon, you're going to have to memorize all this. So put a star by this. Okay? Okay, so tangent of 30. So if I use this angle right here, I would do opposite over adjacent. Got it? Okay, awesome. Alright, so are we good? Alright, we're almost done. Let's flip the page. I'm going to ask you to do the exact same thing, but this time I'm not going to give you an actual diagram. I'm just going to give you one of the trig ratios, and you have to be able to figure out the rest on your own. Okay? Look at number 4. Let theta be an acute angle such that sine of theta equals 0.6. And I gave you a hint. Rewrite 0.6 as a fraction to make this easier for you. So how can I rewrite sine of theta as a fraction? 3 over 5? Now, how is that going to help us? Well, look, if we draw ourselves a diagram, let's call this theta. Well, we know that sine is opposite over, then you know that this is 3 and that this is 5, right? So do you see the benefit of turning something from decimal into a fraction? Are we okay with that? Now, based on just by looking at that triangle, you should be able to tell me what the adjacent side is. This is known as a Pythagorean triple. You should probably have this one memorized. That's the most basic one, a 3, 4, 5 triangle. Okay? There's two others that you need to memorize. 5, 12, 13, 7, 24, 25. Those three, you need to have them memorized. Okay? So I'll repeat them. 3, 4, 5, 5, 12, 13, 7, 24, 25. If you memorize those, your life becomes easier. If you don't memorize them, you can still use Pythagorean theorem, alright? Cool. Alright, so now we have the triangle, and this becomes very, very simple. What's the cosine of theta? 4 over 5. What's the tangent of theta? 3 over 4. Okay? Alright, you should be able to do number 5 and number 6 with your partner. Before you get there, this is the Greek letter. It's known as beta. And this is the Greek letter known as alpha. Okay? Does it make a difference that I'm using a different letter? No. Everything should still work the same. Okay? So I want you to try number 5 and number 6. Put your cups in red and then turn to green when you are done, please. Alright, so if you're watching the videos, please check your answers. Here you go. And then we have one more thing, okay? For tonight's homework, you have a couple of assignments, actually. First of all, you have a book assignment. It's page 280, those problems. Second, I need you to fill out this chart using those problems that I told you to start on the first page. You guys remember the first 3 examples. You're going to answer and fill out that table. And lastly, you're going to complete these notes. They're all word problems, okay? Now, in order for you to do those, I have to make sure that you remember from geometry the difference between an angle of depression versus an angle of elevation. Okay? So let's pretend here's Mr. Carry-On right here. And let's pretend I went to see the Statue of Liberty. Here's the Statue of Liberty. There you go. Alright? So let's pretend I'm on the ground and I'm looking up towards the Statue of Liberty. The angle from the ground, well, actually, if I want to be very technical, I'm using my eyes, right? I'm not using my feet. I'm using my eyes. Imagine there is a parallel line to the ground. So the angle created between that imaginary parallel line to the top of the Statue of Liberty, so I'm referring to this angle right here created, this is known as an angle of elevation. Okay? Now, let's pretend that instead of me being in the ground, I'm actually on the top of the Statue of Liberty and my friend is down here, and I am looking down towards my friend. Well, same kind of scenario. Imagine there's this imaginary parallel line to the ground. So imagine there's this line that is parallel to the ground. The angle of depression, you have 2 choices. It's either this one or that one. Who remembers which one it is? It's on the outside of the triangle. Okay? This is your angle of depression. Because you're looking downward. Okay? Now, here's my question to you. What is the relationship between an angle of elevation and an angle of depression? And why? Why are they equal? Parallel lines cut by a transversal, alternate interior angles are congruent. So, even though they are in different positions, they end up being the exact same measurement. Agreed? It all has to do with the context of the problem. So in other words, this is congruent to that. Okay? Questions? Are we okay? Can you apply angle of elevation versus angle of depression? Okay? Alright, there is only one problem that I actually want to make sure I work out with you because most of you guys will not be able to solve it. Flip and go to number 7. Okay? You're going to need your calculator for this. I need you to clear them. So we're going to go to 2nd plus 712. That clears your calculator. Okay, so we're going to put that to the side for the moment. And I need you to draw yourself a diagram of the situation and then compare it to what I'm going to draw. Okay, so I'll give you a minute to read the problem and draw yourself a diagram, please. Alright, so now that we have a sketch, the question was asking us to find the actual angle this time. And we haven't really done much as far as the notes, as far as finding angles, other than we got lucky that that very first example was one of those 30, 60, 90s, right? And we were able to tell right away, correct? Well, we have a problem that's, of the rules that we know, typically if this was X and this was like twice as much, that's not happening here, right? Or it's not like this is this times the square root of 2 will not give you that, right? So it's not one of those special triangles. Unfortunately, we're going to have to resort to other methods for finding this specific angle, okay? But here's what we know. If you look at this diagram, you have the angle, and that's the angle that we're looking for. We have the opposite side, and we have the adjacent side. The hypotenuse, pardon me. What ratio deals with that? Sine. Agreed? So here's what I want you to do. I want you to write this statement. What is the sine of theta? Sine of theta equals to what? 3.5 over 17.5. Can we all agree with that? Right? Now, at this point, that tells me nothing about the angle. I still don't know the angle. Okay? So, in order for me to find the angle, I gave you a hint. This is where you're going to use that sine and then the little -1 key on the calculator. So, everybody grab your calculator. I need you to locate sine, cosine, and tangent. Here's sine, here's cosine, here's tangent. And right above it, well, in my calculator it's in blue letters. I don't know what color it is on yours. You have that sine with the little -1, the cosine with the little -1, and the tangent with the -1. Based on unit 0, we just took a test over it. What does that little -1 mean? Inverse. So that means that this is the inverse of sine, that's the inverse of cosine, and that's the inverse of tangent. Agreed? Well, why would I use inverse? Let's make the connection. We know that a function and its inverse do what to each other? Say it louder, I heard it. They undo each other. So you recall on this test, when I asked you to show that two functions were inverses of each other, you had to do, and I'm just going to write up here because it has nothing to do, you had to do f of the inverse of x and verify that that gave you x, and then you had to do the inverse of f of x and verify that that gave you x, and that's what proved that they were actual inverses. Well, notice that it's narrowing down to be x. So when you take the inverse of its inverse, it's going to narrow down to just simply be x, right? Well, we're not dealing with x this time. We're dealing with theta, and that's okay. Can we all agree with that? So what happens if I do the following? You ready? What if I take the inverse of that, but it's an equation, so you got to remember that what you do to one side, you have to do it to the other. Okay? Now, based on what I just showed you up here, what's going to happen here? Cancel out to leave you with just what? In our case, will be theta, so I'm going to go up here. So theta equals, and then you have this. If this was on a non-calculator part, that would be your answer. You would be done. Theta equals inverse sine of 3.5 over 17.5, and we would put the symbol for degrees. You would be done if you didn't have a calculator. But if you do, in our case we do, I want you to actually find out what it is. So go to your calculator, and before you do anything, you have to check your mode. So I need you to hit mode, and notice how on the third row you have radian, and the next row you have degree. You don't know anything about radians so far, so we're going to be dealing with degrees. I need you to go to degree, highlight it, hit enter, and then second mode to get out of there. Okay? Now that you're on degrees, now you can actually plug it in. So second sine of 3.5 over 17.5, close your parentheses and hit enter. Now, that means that your angle is approximately what? Approximately, and I'm going to go to 3 decimal places, 536. And let me explain to you why I use 536 instead of 537. Okay? Do you guys see how most of you guys will probably done 537? Because you were rounding. Okay? And that's because I forgot to read the instructions to you all the way up top. You're going to solve all these problems, but you're going to truncate to 3 decimals. The difference between truncating and rounding. Rounding, you look at the 4th digit to determine what that 3rd digit's going to be. So if I was rounding, I would look at the 9 to determine if that stays as a 6 or it goes up to a 7. With truncating, you literally look at if in this case it's 3 digits, you look at the 3 digits and ignore everything else. You just stop there. Cool? The reason why I'm using the word truncating, it's because it may show up on the AP exam if you do take calculus. Okay? So I want to get you used to both truncating and rounding. Any questions on how you can use the inverse to find an angle? Yes?
Would all of these be in degrees?
As of now, yes, because you don't know radians. Pretty soon we're going to learn radians, and then you're going to have to make sure you switch back and forth depending on what the problem says. Okay? All right, other than that, you know your assignments. I'll be here to help you.